Hi, let's start with the concept capsules for today. The topic that we're going to cover is portfolio return and variance. A portfolio return is something that people generally understand quite easily. On the other hand, portfolio variance is something that they struggle with, mainly because of the formula for portfolio variance, which looks quite intimidating really. So what we're going to do is we're going to understand how portfolio return and variance works, and then we'll try to look at a quick trick to understand the variance formula so that we're able to remember it, we're able to memorize it easily. Because this is one of the most important questions that does come in, and it comes in quite often. So we need to understand both the formulas well. So let's start with the portfolio expected return first. The portfolio expected return is simply a weighted average. Now, one weighted average is just like another weighted average. So nothing complicated here really. A portfolio expected return simply means that we have been given multiple assets or we've been given multiple stocks and we've combined them in a particular proportion into one portfolio, and now we need to calculate the expected return of that portfolio. How do we do that? We simply take the weight of every single stock and we multiply it with its respective return. How do we calculate the weight of a stock? It's simply what is the proportion of the stock that you're holding in the entire portfolio. So for instance, let's say your portfolio is worth $100,000 and you hold $40,000 worth of stock A. So in that case, the stock A's weight would be 40%. So that's how simple that is. So let's see how to calculate the expected return on the portfolio. So the ERP, which is the expected return on the portfolio, is given by sigma of WI into RI, which essentially means for every single stock, we multiply the weight of that stock with the return, and then we add all of them up together. So let's try out an example on this to understand it better. So assume we have a simple portfolio of two mutual funds. Now that means we're talking about two different assets. Let's say asset A and asset B. So one is invested in bonds and the other is invested in stocks. Now we assume that the stock return is 8% and the bond return is 6%. And our allocation is equal in both the funds. Now in this case, what will be the expected return on the portfolio? Now the stock return is 8% and bond is 6%. And we're assuming that the allocation is equal, which means that the weight is 50-50 or basically 0.5 and 0.5. So what will be the expected return? That will simply be 0.5 into 8% plus 0.5 into 6%. So your expected return of the portfolio is simply 7%. So that was easy. Now let's look at the more complicated bit. That is the portfolio standard deviation and portfolio variance. Now portfolio standard deviation is not just a sum of the individual standard deviations. Also, it's not simply a weighted average of the individual standard deviations. So it's not as easy as the portfolio expected return. Now, why is that the case? Because in addition to knowing the weight of the various assets that you're holding, in addition to knowing their standard deviations, you also need to know a very, very important thing, and that is the correlation between the assets. Now this gets increasingly complicated because the more assets you have in a portfolio, the more pairwise correlation you will keep having, and the formula will become increasingly more complex. Now in the exams, whether it's CFA or the FRM exam, typically you're not asked anything beyond 2 to 3 asset cases, and 2 asset cases are usually more common, because the formula keeps increasing in the same pattern, and there's no real point of asking a 5 asset or a 6 asset case in the exam because it's just too much for one question. So you should be focusing on the 2 assets and the 3 asset case. There's no real point of going beyond that. Alright, now the standard deviation or portfolio risk is not simply the addition of the risk of the underlying security. So remember, we need to factor in the correlation, and that is actually the most important term that we're going to look at. So the portfolio standard deviation comprises of 2 key parts. And what are those 2 key parts? It's the variance of the underlying assets. That's something that we already need, plus the covariance of each underlying asset pair. So the asset, the example that we're considering, we'll be looking at two different assets. So in that case, we need the pairwise covariance or the correlation for those two assets. So if you had three assets, then again, you would need pairwise covariance, the correlation for all the three. So it's going to become increasingly more complex the more number of assets that you have in your portfolio. Now let's see how to calculate the portfolio variance as well as the standard deviation. Now this is the formula that we have for variance. Now no prizes for guessing how to get to the standard deviation. The relationship is exactly the same as any other variance or standard deviation. Standard deviation will simply be the square root of the variance that you have for portfolio. So portfolio standard deviation is simply the root of portfolio variance. How do we calculate the portfolio variance? Now we have these terms. Let's have a look at what these mean. So Wx, which is essentially the weight of the first asset, exactly like what we did in the expected return of the portfolio. Then we have sigma square x, which is essentially the variance of the first asset. We have the same information available for the second asset. So wy and sigma square y. So we are taking the square of the weight of the second asset and square of the standard deviation of the second asset, or simply the variance of that asset. Now, most importantly, if we see here, we have twice of the individual weights, individual standard deviations, and most importantly, the last term, that is the correlation. Correlation is the most important term when it comes to the portfolio theory, because this is what determines the level of diversification that we have. And diversification is the reason why we are creating a portfolio in the first place. So that's what your formula is. Now, how do we remember this formula? That's something that we're just going to see. So you calculate the portfolio variance like this. And once you have that number, portfolio standard deviation will just be the under root or the square root of this portfolio variance. All right. Now, how do we remember this formula? It looks quite complicated already. So this is the formula that we have. Now let's go back to a formula which you would have done in school in algebra, and let's see if there is any similarity here. All right, and now try to remember this formula for a plus b whole square. A plus b whole square is equal to a square plus b square plus 2ab. I'm pretty sure everyone would remember this formula from school. Now let's compare these two equations. Do you see any similarity here? A square. So we have wx and sigma x. What if we take that? So what if we take a as wx and sigma x and we square it? You get exactly the same thing here. Similarly, if we take b as wy sigma y and we square it, you get the second term. So this is a square. That's b square. Then that's your a and that's your b. So we need to do 2ab. That means 2wx sigma x and wy sigma y. So you end up with this. So you have these four terms. However, the term that this will not be able to give you, and that's something which you need to memorize, is the last one. That is the correlation term. And remember, this is the most important term. Why? Because this determines the level of diversification that we have in our portfolio. So remember, we are doing a square plus b square plus 2ab, but right at the end, we're also including the correlation term additionally. So this is one quick trick of just remembering this formula, but remember not to ignore the correlation aspect, because without that, of course, our question, we won't be able to get the correct answer. Now, why does this correlation really matter? Now we know the correlation is going to range from -1 to +1. It can't really go beyond any of these numbers. It's range bound between -1 to +1. The higher this correlation is, let's say if we move towards +1, the greater the portfolio variance will be, because we have a plus here. So the more the correlation is, the more this number is. The more we go towards the negative side. Remember, we can't go lesser than -1. If we go to -1, then this entire third term will become negative. So that is the lowest amount of portfolio variance that you can go to, which basically means that is the highest level of diversification that is possible for your portfolio. So the more negative this correlation term is, the better it is from a portfolio perspective because it's increasing your diversification benefit. So correlation is the most important term. The other thing which you should notice here is, what if we combine these three terms together? The last three terms that we have here. We have sigma x, sigma y, and correlation between x and y. Now you might recall this is nothing but sigma x, y, which is essentially the covariance between x and y. So if you're given the covariance in the question directly, instead of these three terms, you can simply use the covariance here. If you've not been given the covariance and you've been given the correlation, then this is the formula that you're using. So these are basically the two versions of the same formula. Depending on whether we have been given the covariance or the correlation, we choose which formula to go in for. Okay, so that's your portfolio variance formula. Now let's try out a couple of questions to understand this better. Now we have a 2-asset portfolio. Asset A has an allocation of 80% and a standard deviation of 16. Asset B has an allocation of 20 and a standard deviation of 25%. Now the correlation coefficient is 0.6. What is the portfolio standard deviation? Now one thing that you need to be very careful about in these questions is that, is the question asking you for portfolio standard deviation or portfolio variance? In almost all likelihood, what is going to happen is that if the question asks you for portfolio standard deviation, the answer, one of the answer choices will be for portfolio variance, because they know that this is going to be a very common error. People would compute the portfolio variance and just leave it at that because they've done enough calculation and they forgot that the question is actually asking for standard deviation, not variance. So after doing all of that, they forget to take the under root of that number and the entire, and they lose out the marks for the entire question. So make sure you pay attention to this. So always look at what it's asking for. If it's asking for standard deviation, do not forget to take the under root in the last step. So how do we do this? Now asset A has an allocation of 80%. That means that is the weight of asset A. The standard deviation is 16%. So that is here 16%. Asset B has an allocation of 20. So that's the weight of asset B. And a standard deviation of 25. So that's the standard deviation of B. We've also been given the correlation here. So we have everything that we require to calculate first the portfolio variance and using that the portfolio standard deviation. Okay, now what is the portfolio variance? This is the formula that we just saw. We have the weight of X and the weight of Y, which is basically asset A and B. Remember, A square plus B square plus 2AB. Weight of X, standard deviation of X, we have all of this information readily available and we have the correlation as well. So all that we need to do is plug in all of these numbers into the formula. So this is what we get. Your portfolio variance comes out to be 2.66% after putting this. Now, as you can see, if you stopped at this point, if you forgot about taking the under root, this is choice number B in the options that you've been given. So you round it off to 2.7%. So after doing all of this, just because you did not notice portfolio standard deviation and you forgot to take the under root of that, you'll get the answer wrong. So make sure you always read the question. And if it's asking for standard deviation, do not forget to do this part. This becomes the most important part here because without this, of course, you're going to mark option B instead of the correct one, which is option A. Right? So that's how we calculate the portfolio variance. Now let's look at another example. Now this is slightly more complicated. Now we have equally invested in two different companies. Now equal investment means that your weight of stock A is equal to weight of stock B. That means that the allocation is 50-50, basically 0.5 and 0.5. So two different companies, ABC and XYZ. Now we anticipate there is a 15% chance that next year's stock return for ABC, the first company, will be 6%, 60% chance that it will be 8%, and 25% probability that they will be 10%. In addition, we have been given that the expected value of returns is 8.2%, and the standard deviation is 1.249%. So we've been given, so you can see it's like information overload. We've been given too many numbers. So now we're thinking that what do we do with all of these numbers, right? We're not used to so many numbers in one question. But that's not the end of it, because more numbers are coming up. We've only been looking at the information for ABC. Now we need to look at the same information for the other one, which is the stock XYZ. So we also anticipate that the same probabilities and states are associated with the 4% return for XYZ Corp, 5% return, and 5.5% return. So your probabilities are the same, but the returns are these. We've, just like for stock ABC, we've been given the expected value of returns as 4.975%, and standard deviation is 0.46%. So we've been given this information for both ABC and XYZ. We need to calculate the portfolio standard deviation. Now, how do we do this? Let's say if we have all the required information. By the looks of it, we have a lot more than what we might require really, right? But let's see what is missing. Now, portfolio variance, what all do we need? We need the weights, we need the correlation, and that's pretty much it. So we just have to square it. Remember, a plus b whole square formula. So this is what we require. But the problem is, this information about correlation is something that is missing. So that is something that we need to derive from all of this data that has been given, the various data points that have been given. So what we can actually do is, if you look at the probabilities and the returns, it's giving us an indication that we can actually compute the covariance using this data. Because how do we compute covariance? Covariance is essentially, you take the probability, you take the various returns in X, you subtract the average return of that, then you take the return for Y and you subtract the average return for that. So probability into Xi minus X bar into Yi minus Y bar. Now we have been given the expected returns already. We already know what X and Y bars are. That is straight away given to us. We've also been given the probabilities, and we know all of these states, Xi and Yi. So all that we need to do is compute this covariance. How do we do this? Now let's look at the first scenario. There is a 15% chance that next year's stock return will be 6%. So for the first one, let's do that as an example. You have a 15% probability. Now Xi, that is 6%. That is the first data point that we are looking at. Minus what is the expected value of the return, that is 8.2%. So that becomes 8.2%. Let's look at the same thing for Y. In the first case, that is 4% return for Y, for XYZ. So you have 4% minus what is the expected value of return, that is 4.975%. That is the first case. We repeat this process for the other two cases. So 15% chance, then 60 and 25. So we do the same thing for 60 and 25, and then we add all of those numbers together. That is going to give us the covariance. Now, once we have the covariance, we have everything that we need to calculate this. Why? Because all of these three terms taken together are essentially just covariance. We already know the weights. It's equally invested. That means Wx and Wy are both 0.5. We know the standard deviation, 1.249. So we can put that here. We can square it. And these three terms together are the covariance that we have been calculating here. So let's have a look at the solution. So that's your covariance calculation. We did the first part. So 15%, that was the first scenario. 6% minus the 8.2%, that is for the first stock. For the second one, it's 4 minus 4.975. So that's for the second one. And we repeat this procedure. That's your expected return for both the stocks. That is, of course, going to remain the same. What is going to change is the data point. So the first ones, right? So 6, 4, then we have here 8 and 5, and then we have 10% and 5.5. So those are the numbers that is going to change. We sum all of them up together, and that gives us the covariance. Once we have the covariance, we simply put it back into the portfolio variance formula. We know the weights, so we square 0.5 square. We know the standard deviation. Again, we have squared that. We do the same thing for the second stock. Then twice of the individual weights and the covariance. Remember, these three things are what we have combined into covariance. So Wx and Wy remain the same. And these three things are basically the covariance, and that's here. So we put it here. So so that's how we're calculating the variance. How do we calculate the standard deviation? We simply take the root of that, and that gives us the standard deviation. Okay. So I hope you're able to understand the formula better. So that's your standard deviation. It should actually be the root of this number. So that's just a slight typo. It should actually simply be the root of this. Okay. So I hope you understood how to do this. And remember the quick trick from algebra. A plus b whole square is a square plus b square plus 2ab. Just remember to put the correlation term at the end. And remember, that's the most important term. Okay. So if you do it this way, you'd be able to remember this formula quite easily. So I hope this helps.